Hello again and welcome back to another instalment of the ABC of EVs. Now, a few videos in this series have looked at batteries and the terminology around them, amps, capacity and elements in them like cobalt, but today it's all about voltage. Stay tuned for the details. My name is Martin Lee, welcome to the channel, and if you like what we do here, hit subscribe and the bell icon so you never miss a show. So we know from a previous video that electricity is the flow of electrons between atoms. These electrons can move about randomly. So we use voltage to push the electrons around a circuit. And when we have the electrons moving around in the desired direction, that is current. It's the current that we use to power our devices like light bulbs and, yes, our EVs. Now let's take the analogy that we used in a previous video and apply it here today. Voltage is a bit like the pressure in a water pipe. Let's say you have a bucket of water with a pipe underneath. If the bucket of water is full, lots of pressure and the water will come out of the hose pipe quickly. If you reduce the water in the bucket, you get less pressure, less water coming out of the pipe. Now it's interesting to note that you can have voltage without any flow of current, a bit like the pressure exerted on the pipe, but the valve being closed. We can have voltage in a battery without the current flowing, and it's for this reason that we hear voltage called potential difference, the amount of work that can be done. So what's this all got to do with our electric cars? 400 volt systems, 800 volt systems. Bear with me. Let's get smaller. Let's go down to individual cell level. If you had a cell of 1.5 volts and put a wire each end, electrons would flow along the circuit. Add a light bulb between them and the electrons flow through the light. We then place another battery in the circuit in series. The additional 1.5 volts gives us now 3 volts to do the work. A bit like adding water to our bucket in the analogy to increase the pressure. We're adding more volts. So more force pushing the electrons around the circuit, but we can also add batteries in parallel, as opposed to in series like we just mentioned. This means the flow of electrons will be split between the batteries, so voltage doesn't increase, stays at 1.5, but rather it splits the workload, so our light bulb stays lit for longer. Now, before we continue, let's remind ourselves of the difference between volts and voltage. Voltage is the pressure. Volts, simply the unit that we use to measure the pressure. And we will get back onto our beloved electric vehicles in a second. It's a lot to explain. We don't want to go over it in too much detail, but what we've been describing so far is direct voltage. That is current that flows in one direction. But we also have alternating voltage. That's where voltage alternates direction in the circuit. Of course, see our previous videos. AC and DC, alternating current, direct current. Go and have a look at those. Now it's worth noting that voltage in the sockets at home and at work is not the same all over the world. When you plug your electric car in, it explains why some countries charge quicker than others. Many countries operate 220 to 240 volts. Notable exceptions, North America, Japan, around 110 to 130. So plug in your EV to an American household socket and it's going to take a very long time to charge it. That's enough of the science lessons though. Let's talk specifically about EVs and the real reason we're all here. So, as you know, an EV's battery isn't just one big lump of metal, one big battery, or even one big cell. It's hundreds, thousands of individual cells connected in parallel and in series. Remember, we mentioned that already. So manufacturers can connect a certain amount of cells in a certain way to achieve the direct voltage that they desire. Let's take an example to illustrate. Most EVs on the road now have a battery pack voltage around 400 volts. Teslas might be 350, others may be more. But there are some manufacturers that are rolling out 800 volt systems. The Porsche Taycan is one that springs to mind. But more recently, the likes of Hyundai and Kia making cars with 800 volt systems. But drive those till they're almost empty and you won't see anywhere near 800 volts on the readout of the charger when you plug it in. The higher voltage allows more power to be transferred through the same diameter of wiring with less losses. However, it does have downsides. A battery with higher voltage really needs extra componentry to allow it to charge on a DC charger that's rated at less voltage. So it's worth noting a battery is only as good as the weakest cell in series. And before you go thinking that more voltage equals faster cars, not necessarily true. It's more complicated than that. I mean, Look at the Model S Plaid, still using the 18650 cells, albeit vastly upgraded chemistry, that it started out with all those years ago, and it's plenty quick enough. So that's enough from us today, folks, before we get bogged down in too much detail and before we all get a degree in electronics. Is voltage and volts something you ever thought about before you got interested in EVs? Or is a car for you just a way to get from A to B? Let us know what you think in the comments below. Let's keep the conversation going. Thanks for watching. If you like the channel, please subscribe. We're now on Instagram. Check us out. We are at best_electric vehicle. And we'll see you on the next one.